Hi guys, so let's continue our solving. So for today we have seat reservation manager. So what does it mean? We have to design a system that manage the reservation state of n seats that are numbered from 1 to n, okay? And we have two methods with n where we initialize our seat manager and all seats are initially available. Reserve, fetch the smallest number unreserved seat and reserve it and return its number. Unreserved is a seat with a given seat number. Okay. So we have to implement these two methods actually. So, for example, we have 5 seats. Then we reserve first, second, and unreserved second. Then we reserve second, reserve, and unreserve, then unreserve. 5. Okay. Okay. So here it's what if we have reserve method but all seats are already reserved? So let's think about some questions. So what if no more reserve? Second, can we reserve? So we fetch the smallest number unreserved seat and reserve it. So for example, we have seats like reserved 1, 2, 3. Then for example, we unreserve this seat. And then we have reserve. So we have to find this and reserve this seat. Yeah. So basically method unreserve should point, yes. And okay, so I think that I get the point. So actually, for example, and what if we have something like this? Then we do something like this. And we reserve this one. And now we should point to this number that we unreserved. So maybe we can have like unreserved unreserved PQ, right? And and we also have capacity. All it's called size. So actually we increment or decrement our size. And if our unreserved PQ is empty, then we put this one. Okay. So I think it should work something like that. So the first question, what if no more reserve? For each reserve, it's guaranteed that it will be at least one unreserved seat. Okay, so, and for each unreserved, it's guaranteed seat number will be reserved. Okay, at most 10 fifth power calls in total we've made. Okay, so when we have unreserved seat, we just, yeah, and what values can we have? Like from 1 to n, yeah, we can have like 0. Okay. Okay. Okay, so by default, PQ is min, actually. So let's do it. So we have our seats by default, and when we initialize the seats, we create new int with n. It would be seats with n values. And also we have size that by default is 0. And when we have reserve, and yes, and also we have our priority queue. Like priority queue, it would be indexes, like unreserved new priority queue. Okay, so when we reserve, what does it mean? If unreserved size is greater than 0, else then we poll unreserved seat and we actually reserve this seat. How we do it? We do it like seats unreserved, and it would be index unreserved, like, yeah, it would be index +1, and we return this value. Else we are putting in our yes, and before this we always should increment our size with reserve, and here we should do like seats size equal to size +1. Okay, so we have this reserve method, and how our unreserved will look like. Unreserved method will look like the following. Unreserved. So unreserved method will always decrement our size, and also in unreserved we with unreserved, we should put in our unreserved PQ. We should add seat number. -1. And yeah, we can like put also here, but I think it's not necessary actually. Okay, let's try to run it. And here we have yeah, and here we also increment size. No, we should increment our size like it would be our result. Then we increment size. And then we return result. Okay. Okay, accepted. Let's run it. Okay, so we are done with good runtime. Let's check editorial. Okay, min heap. Yeah, so we have priority queue. We have reserved and unreserved with poll and offer. Okay. Available seats. Poll and offer. Yeah. So here he just use always this thing. So we have min heap without pre-initialization. Yeah, so that's probably something that we are done. Yeah, marker, complexity, log n. Sorted order set. Tree set. Okay, so we also have sorted option here. Okay. Okay, thanks. So that's all for today.